friends, welcome to the Vikasdip Academy. I am Sandeep Wag presenting a lecture on gravitation. This is the gravitation is the topic of class 10 with subject science. Now this is the famous diagram of Newton's universal law of gravitation. Here there are two objects, object having mass m1 and second object having mass m2, and it is separated by the distance d. But the interesting fact is that the force acting on m2 by m1 is equal to the force acting on m1 by m2. म्हणजे काय होतं आहे, एमचं मास जास्त आहे, आपल्याला डायग्रामवरून समजतं आहे m1चं मास जास्त आहे आणि m2चं मास कमी आहे. तरीसुद्धा m1 ज्या फोर्सने m2ला आकर्षित करण्याचा प्रयत्न करत आहे त्याच फोर्सने m2 सुद्धा m1ला आकर्षित करण्याचा प्रयत्न करत आहे. आणि at a balanced condition this m2, which is having less mass than that of the object m1, will rotate around the object m1 having mass m1. The explanation is from the previous this diagram we have seen. There are two objects with masses m1 and m2 kept at distance d from each other, and the gravitational force, we are interested in finding the gravitational force of attraction between these two objects, that is given by Newton. F is directly proportional to m1 m2 upon d square. The terms are already known by you, that m1 is the mass of object 1, m2 is the mass of object 2, and d is the distance between m1 and m2. And when we are going to remove this proportionality sign, we have to put some constant, and here the constant is g, which is nothing but the universal gravitational constant. So next, uniform circular motion or magnitude of centripetal force. So we should know what is centripetal force and what is the centrifugal force. The centripetal force is for rotating objects. Centripetal force is acting towards the center, and the centrifugal force acting away from the center of rotation. So if consider a planet is revolving around the sun, एक कुठला तरी planet आहे जो sun भोवती revolve होतोय in a circular orbit with uniform circular motion. The centripetal force acting on the planet from the sun must be, F is the centripetal force acting on the planet by sun, is given by mv square upon r, where m is the mass of the planet, v is the circular speed, and r is the distance from the sun. Distance from the sun म्हणजे काय, ऑब्जेक्ट आणि सन मध्ये किंवा प्लॅनेट आणि सन मध्ये जे डिस्टन्स आहे, that distance we are calling as radius from the sun. So the distance traveled by the planet, आता प्लॅनेट जे आहे ते सूर्याभोवती सर्क्युलर मोशन मध्ये फिरत आहे, तर त्याचा जो सर्कम्फरन्स असेल, that will be the distance of our distance traveled by the planet, that is given by 2 pi r. 2 pi r is the formula for circumference of the circle. Time taken by planet is considered as t, capital T, and the velocity is given by distance traveled upon time taken. Distance upon time is the formula for velocity. It is we are putting these values into this equation of v, 2 pi r divided by t, we are putting in this equation of in the previous slide. It is the equation of centripetal force. So F is equals to mv square upon r, previous equation we have studied, and we have to put the value of v in this equation of force. So m inside the bracket 2 pi r divided by t bracket square divided by r. v ची किंमत टाकलेली आहे आपण, आणि when we solve this equation we get 4m pi square r divided by t square. Now multiplying and dividing equation by r square. Total equation ला आपण r square ने multiply आणि divide करायचं. Then we get f is equals to 4m pi square divided by r square into r cube upon t square. आता r cube upon t square जो आहे ती term आहे constant term, we call it as a k, and which is nothing but the Kepler's third law of motion. So when we separate the constant terms and the variable terms, we get 4 is a constant, m is constant, pi is also constant, and k is also constant. We are removing these constant terms, we get f is directly proportional to 1 upon r square. Now let's find the value of g on the surface of the earth. So we calculate value of g by using Newton's universal law of gravitation, which is given by where m is the mass of an object, r is the distance of an object from the center of the earth, and m is the mass of the earth. Then f is equal to g m, so capital M small m divided by r square. This is the formula taken from the first diagram, in which g is the universal constant, m1 was the mass of object. On here it is mass of earth is capital M, and the object which is having mass small m is placed on the earth, and divided by the radius of f is equals to m into g. We are known that the Newton, according to Newton's second law of motion, f is equals to ma. Here acceleration is acceleration due to gravity, therefore it is represented as small g. We see equation 1 and 2, we get that force is equal, that is we can equate the right hand side, therefore we get g is equals to capital G, small g is equals to capital G capital M divided by r square. So on the surface of the earth, r is the capital R, radius of the earth, hence small g is equals to capital G capital M divided by capital R bracket square. These whole things are we can calculate by putting these values in this equation. We can calculate acceleration due to gravity. It is given by capital G is nothing but the 6.67 into 10 to power minus 11 into capital M, that is 6 into 10 to power 24, divided by radius of the earth 6.4 into 10 to power 6, and the square term is, as we are taking the square of the radius, we are putting this 2 over this bracket. When we calculate this equation, we get small g is equals to 9.77 meter per second square. Here all the terms are constant, hence value of g is 9.8 meter per second square, and can never be changed according to different properties of an object. This means that this value of g on the surface of the earth is 9.8 meter per second square, and it will not change to any object because there is no any term related to object. These all things are constant, hence the acceleration due to gravity is constant. Hence, thank you very much for listening. Please like, share, comment and subscribe the channel.